Hi, my name is Aaron Feelong, and this is my lab report for Lab 2, Lines of Charge. The purpose of this lab is to use charge tape to compare the point charge model to the lines of charge model, dividing up the tape into segments and treating each as a point charge in order to approximate a more accurate charge quantity for each tape than for the charge quantity that we found in Lab 1. The fundamentals of this lab are using tape to model electric fields of distributed charge, using Newton's second law, which is force equals mass times acceleration, and Coulomb's law, which is force equals the charge times the electric field, in order to calculate the charge on each piece of tape, and using superposition in order to find the charge distributed across each piece of tape in the most accurate manner possible. With regards to the results, I found that the force of gravity should be equal to the electric force, which is about 2.17 times 10 to the negative 3 newtons. The charge on each piece of tape is approximately 2.88 times 10 to the negative 8th coulombs using this model, and using superposition of segments provides a much different and more accurate result than treating the entire piece of tape as a point charge. With regards to the assumptions and models that we used, each piece of tape was modeled as several equal segments, with each segment being modeled as a point charge, each with equal charge, in order to apply the properties of superposition to find the charge of each. We assume that air resistance is a negligible force, each piece of tape has the same amount of charge, and the charge of each piece of tape is equally distributed along the length. So with regards to the experiment, it was the exact same experiment that we did in Lab 1, where the system was tape B and the surroundings were everything else. The initial conditions were the two pieces of neutral tape, and we charged them by sticking them down onto another piece of tape and ripping it off quickly, allowing them to be positively charged as we found out in the first lab. With regards to the data and calculations, I found that these numbers quantified the tape mass, length, and the distance between the pieces of tape. I found that the force of gravity on the piece of tape was about 0.00217 newtons, and that since the acceleration of the tape is 0, the electric force exerted on tape B by tape A must be equal to the force of gravity on tape B, and I was able to derive this equation for the charge, which was 1.34 times 10 to the negative 8th. Keep in mind that this is under the point charge model. Next, we'll move on to my computational model. As you can see, I first initialized the constants and the properties of tape B that are relevant to this model. I then used the following lines of code on the bottom left side of the screen and on the right side of the screen to first initialize a function for an electric field, and then to define the function for the line charge to ensure that each piece of tape was modeled as a line charge broken up into n segments. In this case, I set n equal to 100. These lines of code created the models of the tape themselves. These lines of code then created a nested for loop in which the electric force on each segment of tape B by each segment of tape A was calculated and added together through superposition in order to find the net electric force on tape B. These lines of code finally found the gravitational force and created the appropriate vectors for the electric force and the gravitational force. As you can see, using my value of charge from lab experiment 1, where we modeled both pieces of tape as point charges, the electric force and the gravitational force were not equal. This shows that modeling tape B as a point charge was not the most accurate way to calculate its charge. I then used this equation, which we derived in lecture, for the electric force on a point charge by a line of charges, and got Q to be 2.74 times 10 to the negative 8th coulombs. As you can see, when using this result for charge in the glow script model, the electric force and the gravitational force were closer in magnitude than they were in the previous slide, suggesting that this representation of charge is more accurate than the point charge representation. However, this model is clearly still not perfect, as under this equation, tape B is assumed to be a point charge, while tape A is assumed to be a line charge, which is not accurate. And finally, through a process of guess and check, I was able to come to a value of Q equals 2.8796 times 10 to the negative 8th, which allowed the electric force to gravitational force to be approximately equal. So for the discussion, with regards to this model, it was likely much more accurate than the model for Lab 1, as we split each tape up into 100 segments in order to estimate the charge on each, rather than assuming each as a single point charge. This model is still not perfect, however, as we broke up the tape into a finite number of segments, where had we broken it up into more segments, it would have been even a more accurate answer. Potential sources of error for this lab were that the charge on each tape may not have been totally equal, as we assumed it was in calculations, and the charge may not have been equally distributed across the tape, which may have meant each segment of the tape was not equally charged. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. Had we modeled our tapes as a point charge, as in the previous lab, the gravitational and electric forces would not have been equal as we saw in previous slides, suggesting that the point charge model was not at all accurate. As you can see, 1.34 times 10 to the negative 8th versus 2.88 times 10 to the negative 8th produces about a 53.5% difference, meaning that the line charge model was significantly more accurate than the point charge model. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? These estimates differ because we used different methods of calculation in order to find the charge for each estimate. The second estimate, or 2.88 times 10 to the negative 8th coulombs is most likely closer to the real value, seeing as we took into account the length of the tape with this estimate and modeled it as several segments rather than just as one point charge, and this more accurately models the real-life interactions between the charged pieces of tape. With regards to the conclusions I was able to reach, I found that the line charge model is often much more accurate when it comes to observing charged objects at a macro scale than the point charge model. The difference between the line charge model and point charge model in calculating charge on the object is significant, and when it comes to the line charge model, the more segments an object is divided up into, the more accurate the results of superposition. Thank you for watching.